presenter is Patrick, right? And he will talk about development and testing of automotive Ethernet networks together in one tool for OMNeT++.
Good morning. My name is Patrick Wunner, and I talk about development and testing of automotive Ethernet networks together in one tool, OMNeT++. First, I want to show some background about the protocol that I use, about our middleware. After that, we can create an in-vehicle network step by step. Then we talk about the results, the future work, and after that a little application presentation. For the background, the whole work is based on an implementation of the protocol SumIP with service discovery. SumIP is a scalable, service-oriented middleware over IP. This was developed by BMW. After that, I show something about interface to the middleware that is used for the network initialization, and after that we can change with this variables on the fly. Boardnet engineering is shown, and after that the RESPOS simulation. The protocol SumIP with service discovery. Here you can see where it is located in the OSI model. So it is based on TCP UDP, and because of this we can use the INET framework and extend it with an UDP app and implement in the UDP app the SumIP protocol. The SumIP protocol has no real-time capability, and for this, at the bottom of the OSI model, the MAC layer is extended by a VLAN tag, and the Ethernet PHY is converted to Broader Reach with a Broader Reach converter to send the 100 Mbit data over one twisted pair of cable. The connection in a SumIP based area is a switch network, and here are two nodes. Every node has consumed services and provided services. And every service has a service ID with events, and the events define the payload of the messages. That can be structs, variables, arrays, and so on. And the events are grouped by event groups. When node 2 needs the service 1 that is provided from node 1, then he can subscribe to the event group, and after that node 1 send the events that are grouped by this event group cyclic or on change. So that was the service-oriented communication, and with this we can build up an in-vehicle network. At first there is the boardnet engineering, and by boardnet engineering there is only a simulation, also the natural environment of OMNeT. When the network is built up, then the boardnet engineer defines the data in a network description file such as FIBEX or RXML, and provide this to the original equipment manufacturer, and this has to program the ECU for the boardnet. When he programs his ECU, then he needs a RESPOS simulation, and this RESPOS simulation can be built up with rapid prototyping tools, and with RXML files or FIBEX files he can build up his RESPOS simulation model, and then he can do a little RESPOS simulation. After that, the ECU and the FIBEX description are provided to the test engineer, and he does a hardware in the loop test, and he built his own model for the RESPOS simulation to do error injection, automatically tests, and so on. But everyone has to build his own model from the Firebex file, and there can be errors. And so the idea was to take one model and take OMNeT++ for all these steps. How can we do that? At first, by boardnet engineering, that's the natural environment. So we can define the structure of the network, the number of hosts and the switches, and the data transfer rate. That we can do by the network description file with OMNeT++ and the ENet framework. And additionally, we need a simple way to define the services, the events, and the event groups, and changing the variables on the fly, do error injection, and so on. So this model was adapted by the Gamma 5 middleware. This middleware is then taken by initialization and defines the services, the events, and the event groups in the internal data model of the single hosts, and after that we can change the variables over GUIs or something else. Then the OEM, he has to do then the RESPO simulation for the rapid prototyping, send and receive network data over the network to the ECU, and he has to change the data of the events on the fly. So with a rapid prototyping tool, we can send Ethernet data, CAN, and LIN data, and on this tool, that's the Easy Tester, there is a Linux-based operating system, and so we can build up the OMNeT++ with ENet framework and Gamma 5 model to this tool and send the data over the Ethernet file. And the test engineer, he has also to do a RESPO simulation. He has to send and receive the data. He has to change the data on the fly. And he has additionally to do an error injection and has to do automatically test build up. So with a test studio that can be connected to the Gamma 5 middleware, the hardware in the loop test can be started and be done. On this hardware in the loop tester, there's a real-time hardware, and here we can set up a Linux image, so additionally we can adapt OMNeT and ENet. The results, the SUM IP with service discovery simulation and the RESPO simulation is working. And the Gamma 5 connection can be done by initialization and by running the simulation. For the future work, there has to be some research in other protocols with hard real-time requirements to show the limits of this solution. And the automatically test build from a network description file, Firebex or RXML, has to be done, and the error injection has to be implemented. So at least the application presentation. So at first we have to create the data model for the Gamma 5 middleware. And this is XML based, and so we can define the provided services with the service ID. Is the service ID? And there are some variables that are taken for the communication between the nodes, and then we can define the events with its variables or structs or arrays. And then we can define the payload of the single messages, very simple. So we add the variables, can define the name and the type, and with the name we can change later the variables. And the single events and services are read out by initialization of the simulation. After that, when the simulation is running, we can manipulate the data or do maybe later some error injection over GUIs. So we have to start the middleware. After that, with tools like the Gamma Explorer or something else, we can manipulate the data. And for this presentation here, you can see the single nodes. And every node has consumed and provided services. And every service has events and event groups and its own variables where you can define the data or change it. So when the model is built up and the service is running, then the view simulation can build up. So here a single network with 2 switches, 3 hosts, and as UDP app, the UDP sum IP. And we define the data rates and the connection between the nodes and the switches. The configuration is done over the configurator, or the IP addresses, and for the RESPOS simulation, the routes. With pcap recorders, we trace the network traffic, and so we can show where are bottlenecks or something else. And when the simulation is initialized, the events are read out, and now you can see how the service discovery is subscribe and acknowledge to other services. After that, with this model, we generate a RESPOS simulation. So we take an external router. The routes are defined in the config XML, and remove the host 3 that we have now on a real ECU that is connected to the network card of the simulation host. Remove it from the simulation. Then the pcap recorder can be taken, and we have to define the filter string. And the device here, it is ETH 1.73 for VLAN ID 73. And we have to do an express run because we need special times for the RESPOS simulation to the external ECU. And after that, we can have a look how the single nodes subscribed to each other, or can look at the trace with a pcap file. So at least the build-up with the easy tester. So here you can see the model and the real ECU that is connected over Proto-Reach converter. At the back here, the simulation is connected over standard Ethernet to the easy tester, and there's one Gamma 5 service running, so both simulations work together. And we can do some motor simulation or send LIN or CAN data to the ECU and have a look how this ECU is working. So that was it, and thank you for your attention. Do you have any questions?
So you're using the simulation with a real-time scheduler to interact with users.
Yes.
But are you using the basic infrastructure provided by INET for talking to an external interface?
Yes.
And do you run in any speed limits? I mean, you need to have some.
Yes.
The simulation needs to keep up with real time. So have you any problems with that?
At the moment not, because at now systems audio video bridging is not taken, and so we have time limits of maybe 10 milliseconds to 20 milliseconds where we have to send the data out to the network, and that is no problem for the solution.
More questions? I mean, otherwise we have the discussion part